for this section of our class, we're gonna record it and okay. So as I said earlier, that we're going to cover the GIS system. So I've managed to open the website for it. So here's the system here. So as you can see, we are having the GIS of the whole of Gauteng, and under this GIS, you are able to view things such as if you wanted to focus on sports and recreation or restaurants, hospitals, fire, police stations, fast food. So this is how you would do it. That you see now the boundaries now you choose. If you wanted to say I want to see airports only, you would do the airports. Where are your airports here? I believe this is an airport, the one in Alberton. This is OR Tambo. There's another airport here. There's another one here. Is it Lenseria Airport? And if we were to go to the south, Alberton, okay. Sebokeng, around about Sebokeng, there's another small airport there, Aeroval. That's another one there. So as you can see, this is helping you to see certain things that you never thought you had. And if you wanted to see what is a toll plaza to your, I believe your toll gates, this is a one here. Your toll gate there on N1. So if you wanted to see fire police stations, like cemeteries, city parks, sport grounds, if you wanted to see towns, you want to see fast foods, outlets, museums, and stuff like that, all these things that you want to see, you can always press and then you zoom out and you see what is happening there. So yeah, this is a GIS system people utilize to see certain things, and the more accurate ones would definitely tell you about zonings and stuff like that, so you can utilize it as part of your decision making when you're choosing your land site, because it can tell how far schools are from you, how far hospitals are from you, how far are certain aspects. Even Google Maps can do that on a serious note. Even Google Maps can definitely do that. Let's not act as if it doesn't. Even Google Maps can definitely do that. So, and with Google Maps, you can earmark a certain areas. As you can see, these are the areas that I've traveled. I tend to. So as you can see, there's museum opening there. There's places such as uh, University of Johannesburg. You have your GP High School. You have your Constitutional Rights Hill. You have your ZCC there at Josh Koch, and your Bloemfontein, Kronstadt, Welcome Texas there, and you have Kwamaimai. Let's not ignore Kwamaimai. It's now a site for noting. We have Gandhi Square. If you go to the Val, this one is much even faster. It shows everything by default. You have your Northwest University, and you have your campus. Even your Desmond Tutu Square is there also. You have the University of Val Stadium. So it shows a lot of stuff. Your mall, a lot of stuffs are now appearing free of charge. Even your daycares, you can sort by daycares if you want daycares. You can sort by restaurants if you're looking at the sorts such things. You see now, you will see how where are your restaurants. You have maybe places for sleeping, hotels also. You can just, even with prices of hotels. So you see now, these systems are very critical when you are choosing a location for your company. Okay, so okay, for the business of the day, we are going to be focused on the examples that we spoke about. Right, we're just gonna fly through them. We have done productivity. I don't need to show you productivity once again. We've done it, but you need to understand. So now, as this productivity in the case of in the context of choosing a plant, when deciding on location, management may be tempted by an area low wage rates. Ne? So, wages are something that you need to consider. However, wage rates cannot be considered by themselves. They cannot be the determining factor by themselves. As Otis Elevator discovered when it opened its plant in Mexico in 1998. But by 2011, Otis found to move an automated plant in South Carolina more advantageous. Management must also consider productivity. As discussed in Chapter 1, differences exist in productivity in various countries. So you see now, difference based on countries, productivity differ based on countries. What management is really interested in is the combination of production and the wage rate, the relationship between production and the wage rate. For example, if Otis Elevator pays $70 per day with 60 units produced per day, in Carolina, South Carolina, so 70 per day with 60 units, high wage, high units. It will spend less labor than at Mexico that pays 25 per day with production units of 20 units per day. So you make a quick comparison calculation fast there. Obviously, labor cost per day, and you make for the two plants The other one, units 70. Okay, this productivity looks slightly different from what we are used to, because we are used to productivity being P is equals to output, because productivity is the ratio of output and input. But in this case, we have wage and unit, so that you get it as a dollar per unit. It's still not a problem. So because like that's the only way. Otherwise, you'll have to flip it through a calculator and say 1 over that answer you're gonna get. So and you don't want that. So this one has changed slightly. So because they say management is interested in the combination of production and wage rate, and they want it in monetary value. They would want to know what is the production rate based on monetary value, cost per unit. I'm not sure if they did mention it that they're interested in cost per unit. But yeah, what this statement is, spending 25 with production of 20 units per. So you can see that yeah, the interest is in the money per unit, and that's why you have 70 over 60, which is $1.17 per unit, and also the 25, which is 1.25 per unit. Okay. Although this is very weird, I didn't get the conclusion. This 1.25, it's a higher cost per unit. So what does this mean? Yeah, I'll have to get back to this one. When I start to do problems, I'll definitely figure it out. It's no problem. So this one we've already done it. When you are using weighted scores, 0.25 multiplied by this and that. And obviously you're going to get these values. At the end, sum them up, you get that. And you choose based on what you are getting there. Okay, next up, we're having this one. Yeah? We just did this last week. My pen disappeared. I have two screens. When I'm home, I have the luxury of two screens sometimes. Okay. So, ladies and gentlemen, I have managed to determine how to draw the graph correctly, thanks to the use of a software called QM for Windows, which I will introduce right here and right now. So I think I will see how best can I maybe incorporate it in our labs. The software is already available, guys. The software is purely for the use of operations management, any topic you can think about can be done with this software. I just hope, because I'm using my personal laptop, I just hope I do have it here on my personal laptop. But yeah, because I was doing everything, I was rehearsing on my mm, work laptop. But yeah, if it happens that I don't have it, I'll have to install it so that you can see the procedure also, which is it's a win to you guys. So now we have is Ishmael. I don't know how to read this. Mohebi, owner of European Ignition Manufacturing, needs to expand his capacity. He is considering 3 locations. You see now, the alternatives we used were not looking at locations. Now, the alternatives that we're looking are focusing on locations. And they did mention that you look at variability and fixed cost, variable cost and fixed cost per location. And the rule of the fixed cost, high fixed cost, low variability, high variability and low fixed cost still apply. Don't know how they really determined that. Don't ask me. It's something that we need to investigate. So, so this is more like, to me, A, B, and C for a new plan. The company wishes to find the most economical location for an expected volume of 2,000 units per year, right? So Mohebi conducts location cost volume analysis. To do so, he determines the fixed cost. The fixed cost. Yeah? Then they have, oh guys, I've heard my own voice. 30,000, 60,000, and 110,000 respectively. And the variable costs are as following: 75,000 per unit and 45 and 25,000. The expected selling price for each ignition system is 120. Okay. And the common way we like to put this would be to have our companies at the top, the A, B, and C. We start with what? With the fixed cost, 30,000, 60, and 110. Straight done. It's a mission impossible. All right, and then the variable cost goes like this: 75, 45, 25. The unit cost is 2,000. Okay, then first thing first that you need to determine is the cost, the total cost at 2,000. At 2,000 before you determine anything, the break-even point first with the 2,000. So this is what I would expect any student whenever we do this task. I think that's how, maybe even how I would pose the question in the test. Never mind the exam, but in the test, the upcoming test, because obviously when I was preparing for the exam, yeah, we're doing things for the first time and reading so that you get questions. But now for the test, this is important. I want you to do the proper analysis, starting with these costs. Starting with these costs. So total cost for A equals to $30,000 plus 75 multiplied by 2,000. Cost for B, cost for C. This one I don't have space, I'll just write it here. Okay, I'll do this. Then for B, then for C. Then this one, it's 180,000. No, something must come up here. Yes. Seventy-five multiplied by 2,000 equals to plus 30, which gives you 180,000. Then over here we have 60,000 plus 45 multiplied by 2,000. 45 multiplied by 2,000 equals to this plus 60, which I see 150, plus 60,000 150,000. Then the last one, 110 plus 25 multiplied by 2,000.
So the answer is 160,000.
See, I like it when people are weak. Thank you. Okay. Then 25 multiplied by
No, the answer is
2,000.
for C, sir. 160,000. It's for C.
Oh, thanks, man. Thank you. This one is 150 and then this one 160. All right. So now, yeah, this is at 2,000 units, meaning our X. Remember, these are our Y's. All these are our Y's. They're going to the Y diagram. Y axis, I mean, and then X is it's 2,000. Yeah. So now let's go right along. Now we want to find the economical points. So these are the costs at 2,000. This is what you're getting. But now we want to find the economical points, the break-even points. And the lowest cost is 150, so which is B. Okay, but it's B when you're producing a specific amount of products. See, now we want to say economical, okay, economical volume. Now we're looking for economical volume, né? Between point A and point B. Then we have 30,000 plus 75, x equals to 60,000 plus 45x. X is equals to, what do you get? Okay, sorry, there. You're getting 30,000, right? Here. What are you getting here? 45 minus 75 minus 45.
It's 30.
Then what's our answer?
1,000.
1,000. Okay.
Yes.
Right. Then economical volume or crossover point between B and C. Which is 60 plus 45x equals to 110 plus 25x. Okay. X.
It will be 50,000 all over
50.
20.
Yeah.
Answer is 2.5.
All right. Our answer is 2.5. X is equals to 2.5. Okay. So these are your x's. Okay. These are your x's. We haven't yet determined their y's. Yeah. So let's do their y's quickly. So determining the y for 1,000, x at 1,000 units. So we want to determine the y. What is affected under that? We are only having the one for A and B. Yeah? So y for A equals to 60,000, yeah? Plus 75 multiplied by 1,000. You see that? Then your value is
135,000.
135. To your surprise, you'll realize that this is the same, which is what is this one? No, guys, I'm making a mistake. This is a 30. Why don't you stop me? This is a 30. 30,000 multi, yeah, 30. This is a 30. Can you please rectify for me?
105,000.
Yes, 105. Then 60 plus, this is a 45, multiplied by 1,000. The answer must be the same. What is your answer?
Yes, it's the same, 105,000.
You see then, when they say for point B, it's between. You remember that comment? It's between a certain number and a certain number. It's clearly telling you that when we go x at 2.5 for y b is equals to 60 again plus 45 multiplied by 2.5 now. Okay, what's our answer?
172,500.
YC equals to 110 plus, I think it's 25 multiplied by 2.5.
So, sir,
The answer should be this. Yebo.
So how are we gonna know for option B that we are supposed to use 1000 instead of 2.5?
No. Look, we have two x's, remember.
Yes.
B is the only one that we utilize twice. Remember, we found A and B and C. Understand? So
Yes.
now, when we had A and B, we got 1000. So you need to do YA and YB. Then when you repeat again for X at 2500, which we found through here, which we found through B
BC.
and C, it only makes sense to incorporate the B again. And that's why we're looking
Oh.
for B, and then yes, and then the values are the same, 172, 500. So this tells you that uh, when you look at the graph, remember this is your Y values here, and then you look at you match the Y values on the X axis, then you'll see that you're gonna get all the straight line graphs basically. So now let's come and draw the graph here. I need to, because we no longer, yeah, I need a mouse. Then on the graph sheet now, yeah, on the graph sheet, I'm just gonna do this now here. Call for the ruler.
So, sir, it's always like A, B, B, C, or it's depend on a question.
It's always like this.
Okay.
It's always like this. Yeah, yeah. I don't think I have the capacity to do it differently.
Okay, sir.
Yeah. Now remember, if something I feel like it can change, I'll tell you that no, this one can change. There are these possibilities that you can explore. But if I don't, no, I won't even need not try to be smart. If I try to be smart, I outsmart you and I outsmart my performance. Uh, your performance is my performance, guys. Okay. Uh, we have 1000, 2000. Maybe if I can do get 500 more class, I'll use 500. 500. I don't know what it's acting funny. 1000. Something is wrong. It's my mouse. Okay. 1500 and 2000 and 2.5 and what is this? 3000. Okay. Then we want to go until what's the maximum? I think 180. Want to go to until 180. So let's say 10, no, 20, 40, 60, 80, 100, 120, 140, 160, and 180. I think it will do 20, 40, 60, 80, 100, 120, 140, 160, 180. And then now we need to get our straight lines. Firstly, identify them on the x-axis. Oh, lolo. Hey, winner. We have at 2.5. Okay, at 2000 also. At 1000 also. Okay, then we have okay, the cost for Y now. No, the costs. This cost, where are they? Where are my costs? Okay, all right, which is 30. $30, $60, and $110. Right. Now we have our graphs now. We have our graphs. This is the most interesting thing now. We need to locate these points. For A, we had what? We need to go on the side. 105. Yeah? For A, 105 there. Let's look for 105. Where's our 105? For 1,000 units. This is 105 here. Highway. No, don't do that. Let's use a different color, red. Somewhere there. Good. It's coming from 30 to there. You see that? It's coming from 30 to there. Then we have, and it's going where? It's going to 180. It's going to 180 at 2000. You see, it's going to 180. Why am I not winning? I wish I had my touch screen. Okay. It's going to your 2000 there at 180. Remember, we had a total cost of 180 at some point at 2000. You can indicate the total cost also on the straight line if you have to indicate them. All right, and then another total cost was 150. 150. 150, something like this. Okay, let me just draw a line first. And yeah, there's a point there. The point will be here. If you practice this, you will be sorted. Then the last one, I am forgetting the number of that cost. What was it? 160. Okay, we had what? 180, 150, and then 160. So now that's your A, B, no, that's your C, okay, C, and then that's your B. That's your B, the minimum one. Okay? We did mention that our B is the least one there at 150 there. It's the least one. Okay? Sharp. Then now we have 105. I don't need to, I've already drawn the 105 there. So let's go for another one. 105. So you will see that A and B, they need to pass 105. This is what it says. At 1000, this is what it says here. You see here, A and B must pass 105. 105. So it's for both of them, right? Then, so now we do this. For this one here, 30, which is your A. Something like that. Okay. Obviously, it's not a chance play to get the right thingy, to get the right scale, but this is where it must go. So it passes this point and it goes there. So unfortunately, I'm unable to pass it there to go to the right location. All right. And then for B, B, I believe it's 60 thou. So B, it's going there. So for this, yes, Tapelo Manaka. For B, we are going there.
Sir, I think we have to attend other classes now.
What time is it?
It's 10:06.
No, it's not a problem. This is recorded. I'll continue because it's a recording. You will get the recording once I'm done. It's not a problem. You can go ahead, guys. Apologies for that. Thank you, guys. Right. So I can even change the color if I want, but obviously in a test you don't change colors. Then this one goes like this, and then you can see that we have it goes to B there. From there it goes to a point where the common place for Y, A, and B. You see, then it goes to another point here at 2000. As you know that at 2000 we have the 180, we have the 160, and we have the 150. Never mind that 7 looking like number there. It's 150. It's not 750. What was it? It's 150. Okay. and then after that you have for the what's the next value, 110. So 110 is around here. So 110 has to go to its value also, which is there. Something like that. Okay. And even though we haven't yet determined the where these points are intersecting at 2500, because that's another intersection point at 2500 units. So now these, they need to go all the way to the second intersection for C, 172, for B 172. So from here they were supposed to intersect at around before 18, at around this place here at 172 500, both Y, B, and C. They intersect at another point. Okay, and just now we will move to the software. Let me finish the. I'm going to finish the. I'm going to finish for the gravity. So I'm going to move to the example for the gravity. So for the example of gravity, it goes as following. X for the X core is the sum of xi qi, quantity at that value, sum of over the sum of qi. Yeah? So we need obviously to have a straight line. So write all your values. We have for the x coordinate equals to Chicago goes with 30 there. All right, I want to do dual. Let's see if I can do it. Y is equals to Chicago, X 30, Y it's 120, multiplied by 2000 plus with Pittsburgh is 90 multiplied by 1000, 90 multiplied by not 90, it should be different values, which is Y values. It's 110 multiplied by 1000 plus New York we have 130 multiplied by 1000, 130 multiplied by 1000 plus Atlanta, which is 60/40, 60 multiplied by, I think this one is 2000, 40 multiplied by 2000 again. Okay, then under we have 2000 plus 1000 plus 1000 plus 2000. Under here we have 2000 plus we can combine those two, 2000 plus, yes, I'm fully aware that there's another class running, but this isn't recording, so you are not going to lose anything. You can go to the next class and you'll find the recording immediately after your class. Feel free to go another class, guys. Don't stay. 2000, which is equals to. So the one at the top, we do this 30 times 2000.
So the one at the top, the answer is 66,67.
Thank you. 66,67. The one below.
It's 93.3, sir.
All right. 93.3. So those are our center of gravity. So you'll choose your location based on this coordinate. So now let's go to the use of software to determine some of the problems. So guys, what is happening with the software is that the software can almost solve any, if not all, the problems in the textbook. So that's how powerful our software is. So if you're not sure about how the answer is derived, you can put it in the software. So what is the software? Called, it's QM for Windows 5. And this is our software. Close. And it has modules here. The one that we are looking for is crossover. The one that we were given had 3 costs, which was fixed, variable, or fixed and variable, 2 costs. And it had 3 options. Okay, click OK. So just like this. Option 1, which was A, B, and C. And fixed cost was, if you still remember, 30,000. Option 2 was 60,000. Option 3 was 110. Then variable cost was 75. This one was 45, and the last one was 25. And then the unit cost, which is fixed, is 2,000. And you click solve. And break-even points now. Here are your break-even points. We have 1,000, 1,006. I don't know what is this option for. And then we have the 2,500. Yeah, the 1.6, I don't know how do they determine it, but we're not necessarily looking for it under our calculations. And then we're looking for the guys. I can hear myself.
So we have another class to attend. It's already late.
Yes, don't worry about me. Go to your class. Now I'm recording again for the purpose of the recording. That's why I'm recording. So leave me recording. Don't worry. I will publish this recording once I'm done. You don't need me to be part of this class while we have another class. You can just go and then I'll finish up my recording. Because you can't expect me to restart afresh whilst I can just finish up the recording and then you'll find the recording. If you're not understanding, you'll consult on Wednesday or Thursday. So these are the dollars, 105 and 172. For option 1, we got 105 indeed with as you can see, that's your 105 and that's your 172. We did get these results. And then for the cost, total cost at 2,000 units, we got 180, 150, 160, and we did get them indeed there. Here, 180 there, 150 there, 160 there. And the graph looks like this. The graph looks like this. The volume at 2000 is critical also, and it will look like this. So as you can see, at 172 we have this one combining, and at 1000 we have these ones meeting at 1000. Then you make your conclusion which one is the best and according to how. So you see this is, and even for the what you call this other one, this one, you can find it for a matter of fact, you can find the one for center of gravity. Just that I can't see it now, but I did solve it using the same method also, as you can see here. Center of gravity. I just don't know the name of it. Yeah, but you do find all the problems there. And then I want you to go to try the software to do problem 7.1. 7.1 using the software. And if you did attend, you'll realize that we had a problem drawing the graph. Nah? And I want you to provide the handwritten graph for this example and give me the software graph. So where is the software? The software is under your Blackboard, already published. There's the software there. Once you click on it, I'm sure it's going to download. Save. After it finished downloading, you don't open it, you open the location first. You right click here, you extract like that. Then you install by double clicking and following the prompts. You say yes, and then you continue until the software can work. Then you do the exercise 7.1 and you submit. You submit by tomorrow 12 p.m. You submit this by tomorrow 12 p.m. Mind you, even your forecasting problems can be done on this software. Your forecasting problems can be done on this software. Time series, your time series, your regression, your error analysis, your least square, sample, and multiple regression. All of them can be done on the software. Your decision trees, everything can be done on this software. So for now, to force you to know to use the software, I want you to make a comparison between the software graph, or let's say results, of handwritten results for problem 7.1, and you utilize it by hand, you draw it by hand, and then you draw it by the graph. People will ask me a silly question: how do we then move the graph? I've messed up my work. Yeah, clearly I've messed up my work. We'll be having, actually, this imagine these are your results. You go to an app called Snip, snipping tool. Take a snipping tool, do this, you go to Word, under Word, you paste, enter, you do the same thing, you paste. And this is how I got the graphs and the information. After you click solve, 7.1 is your problem. You need to do it. I need to expose you to the software as soon as possible so that you can utilize it to solve any problems in the book, and you can get the answers correct every time. And you compare with your handwritten problems. I hope we are clear. And this is the end of my session. I'll put this problem on Blackboard right away, immediately after stopping the recording, and I will see you in class on Wednesday and on Thursday. Your scripts will be available on Wednesday and Thursday. Although tomorrow I'll be in office, but I'll be dealing with the ops guys, so I don't want too much obstructions and mixing of students and stuff like that. Let's just meet Thursday and Wednesday and Thursday. Sharp. Thank you, guys. Do we have any questions? I believe everyone who's left here, they were just cruising, accompanying me to the end. Thank you.
Thank you, sir.
Sharp. Bukamusa, were you not attending?
Mem said no. Mem said that we're not gonna have class.
So, and then everybody else just left and never came back.
Nah, they didn't check
Right?
their email. They sent an email.
But I'm surprised the fact that they never came back, even when they realized that they don't have class. But it's fine. It's
Yes.
fine. So yeah, this exercise I'm giving you actually is just going to fast track you in the use of the software, and all the problems, as I'm saying when Nabukamo says that you're gonna get answers for all the problems in the book. So if you, that's why I want to force yourself to utilize the software. Then I might incorporate it in the labs because I'm not happy with the type of labs that we are having right now. So yeah. So yeah, I think that's it for me, guys. We'll see you.